500.
Mm-hmm.
And then remember I was saying I
The
wanted to,
500 was for
you just said
So
because it was
we
100
have
was
four online.
Arab.
I'm just going to start,
that's what I'm saying. I'm saying
if it's
Mm-hmm.
all right with you.
yeah, I took out 500.
So I'm just going to
Then
mute.
400,
Uh-huh.
which means then 100,000 I paid to Ray.
Okay, he was just talking. So, okay, good morning to you all. I hope you're having a nice Fab 16 experience. We started very early for us today, not so, not so much for most of you. And welcome. Thank you for the patience in listening to me. I've proposed a rather weird workshop on computational thinking and 3D modeling because that's some part of what I do as a teacher. And basically, the idea of this workshop is to show you, to talk about a bit of the concept of computational thinking. Of course, it won't be a very deep dive into the concepts because the computational thinking framework, all the ideas around it, it's a bit more complex, and it would need a very specific type of workshop in order to perfectly explore it. And basically what I will talk to you today, because let's face it, a workshop in remote learning is always more of a talk than than an hands-on session, alas. So I'm just going to assume it. I'm going to talk a lot, and you are of course always welcome to using the chat or interrupting me to 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 put any questions that you would like to put. So, welcome to the Computational Thinking in 3D workshop at Fab 16. It's an honor to be amongst you. And let's begin by speak a bit of myself, because after all, one of the great things about the Fab Lab, about Fab Labs and the Maker movement is the way that different people from different backgrounds and in events like this from different parts of the planet get together, share knowledge, and learn about themselves and about what we can do. So basically, as you can see, I'm just a primary teacher. I'm not going to try I'm not going to try to make comparisons between my country's school system and your country's school system, because it would be a bit wasteful in terms of time. But basically, I work with children aged between 10 and 12 years old, what we in Portugal call the fifth and sixth year of basic education. And what do I do with my students, with my pupils? I try to challenge them. I I teach ICT, even though my background is in arts, and I try to challenge them to use ICT tools as creative media in whichever ways they see fit, of course, within the frameworks of my class, within the frameworks of the discipline I teach, which is ICT, as I said. But basically, I try to challenge them to use coding, to use robotics, to use 3D as a means of expression. As in, I try not to teach coding and robotics as useful subjects. Of course, being useful, being utilitarian is very important. I try to teach them to go a bit beyond that, in which the children, the kids that are more creative, that are more artistic inclined, can see in those tools, in coding, robotics, 3D, etc., a way to express their creativity also, instead of, how can I put this in a simpler way? Instead of teaching them, for example, to model in 3D a project for example, addressing a real world problem, I try to teach them how to model in 3D to express themselves and to create. Because I mean, it's the most important thing that we have the idea of imagining and creating. And I'm also very interested in what children can do using their mobile phones and their mobile devices, because I don't know about you, but in my educational setting, it's very hard to have a situation in which I have one student, one computer. I generally have classes of about 28 pupils and about 14 to 15 computers, so they always have to share them. But in a in the lately I've been thinking, wait, I don't have in my classroom enough computers for my students, but they have computers in their pockets. They're called smartphones, and nobody really thinks how to use them to do more than just than just play with them, than just to play games or to use social media. But they can do so much more. So that's one of the things that I'm really involved in, is in trying to find ways to use the smartphone. And I prefer tablets because I'm an old guy. I like big screens. My students like small screens. How to use tablets and smartphones in educational settings, and specifically in ICT class. So onwards. Basically, it's important to underline this. Uh, the this whole workshop comes from my teaching practice. This is not a theoretical workshop. It's actually the other way around. It's a cool. At least I think it's a cool way to see how to see how a theoretical framework, namely computational thinking, which is rather recent, as you may know, um, kind of becomes a part of a teaching practice, even though that teaching practice already existed. So, first things first, why working on this idea of computational thinking and 3D? Just I'm getting ahead of myself. First, because I think it's extremely important to, uh, to use ICT technology, digital media, digital tools, not just as consumer tools, not just as utilitarian tools, but also finding ways to mix art, creativity, and digital tools. Second, everything I'm going to tell you today comes from the field, comes from my practice, comes from my pupils, comes from my ICT class or my robotics club, which is also a very cool place to be at my school. And finally, the idea that we can, as I've already said, use mobile devices as creative tools. The idea that the smartphone, the tablet, can be much more than just a tool for playing games or using social media or communication, can be also a productive tool. I've actually this year, due to the pandemic, I have to reshuffle my entire practice, and I've worked specifically only with mobile devices. And at the end of the year, one student just told me, "Teacher, I did not know that we could do so much with our smartphones, because until then he only knew how to game, how to communicate, how to use social media, and in my classes he learned how to use a smartphone to create games, to code, to do 3D, and etc. 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 So onwards. So what is the framework that supports this whole workshop, this whole idea? It's the framework of computational thinking. Computational thinking is a somewhat new idea in education. It was first framed by the Microsoft researcher named Janet Wing. I'm just going to share. Certo, obrigado, sair daqui. It was originally framed by Janet Wing, a Microsoft researcher. And the cool thing about her proposal is that even though it was very much picked up by the educational communities, it is more wider than that, because we educators took the idea of computational thinking and delved very deeply upon it. But if you listen to Janet Wing, if you read her papers, you'll see that she looks at computational thinking not in specific educational terms, but in the ways that you can of how you can use computation, how you can use the 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 processes, the thought processes, the modes of computational science in other areas. Janet, for example, always uses the same example, the idea of computational biology, or the idea, for example, of digital humanities, because with digital tools, we can go so much beyond the traditional practice in sciences. For example, in digital humanities, we can, it's not about using digital tools to write these essays or to assess or to acquire data. It's more to use digital tools to look in different ways. For example, in digital humanities, why not? It's possible, it's already done. Do a 3D map of the surface of the painting in order to better understand the brushstroke, the brushstroke of the artist. I mean, it can be done. It's already been done, and it's not. How can I say? It's not. It's a novel way of looking at things that we already know sometimes, or you can find, or we can find using computational thinking novel ways of understanding our own reality. Let's bring back my presentation. So I don't know if Megumi, I know that knows a lot about computational thinking, probably far more than than I could than I could say to you. But in a nutshell, for those of us that are not educators, computational thinking can be basically very resumed, very summarized into concepts. The idea of expressing problems and solutions in ways that the computer could also execute, which is, of course, paramount to the idea of applying computer science techniques and modes of thought to other areas of knowledge. These are, to put it very simply, two of the main tenets of computational thinking in education. So in education, we divide the computational thinking approaches into several areas. The idea of using logic, the algorithmic mode, creating algorithms, making rules, finding how to address a problem step by step. The idea of decomposition, breaking the whole down into parts in order to ease the process of solving a problem, finding patterns, recognizing patterns. Abstraction is terribly important. It's probably abstraction and decomposition and patterns are the three key concepts of the computational thinking that got me thinking on the link between CT and 3D. Of course, evaluation, which is a positive feedback loop process, because evaluation, if you are doing something right, keeps happening in real time. Welcome, Kenichi. I have not mangled your name too much. And of course, how to approach computational thinking by tinkering, which anyone that is part of maker culture and uses a Fab Lab is very well familiar with. We tinker, we experiment by creating, by developing, designing, making stuff, creating stuff, debugging, which is, of course, do not fear the mistake, not fear the error. Do not fear the error, and of course, persevering, which in education is extremely important. The idea for students that they should not give up, even if at first it may seem too much difficult. And of course, the idea of collaborating, working together, which in a classroom or in a maker setting, in a Fab Lab, is of course paramount. In education, it's also paramount. The idea of teaching kids to be self-sufficient, self-reliant, but also be able to cooperate amongst themselves in order to develop projects that can be targeted, have a specific team, or that can be free, that children by themselves choose and propose. So, and now looking a bit deeper into the main concepts, into the key concepts of computational thinking, I'm just going to start. This is the wait a minute, please. Tutu? Sim, sim. Sim, sim. Impossível. É assim, podia-me ligar daqui 1 hora e meia? É assim, eu estou no meio de uma sessão, não posso agora falar. Eu já ligo, está bem? Com licença. Sorry, it was a medical emergency. Not worrisome. Okay, so where was I? We were into the computational thinking frameworks and approaches. Now I'm going to to start exploring. This is a theoretical part of the workshop in which I will explore in which I will try to explore the link between computational thinking and 3D modeling. Okay, so the first thing I'm going to pick is the idea of abstraction. And look, I'm holding a pencil in my hand. Really, I'm holding a pencil because a pencil is the metaphor I've found in order to explain this to adults. To children is very easier. I just challenge them to think about the bird, to think about the car, to think about a monster. They always love that one. Think about a flower. How can you do this? How can you do it using the 3D modeling tools? So let's look at the pencil, right? And let's think. We have to model this in 3D. What do we have to do? So the first thing that comes to my mind is the idea of abstraction. In order to recreate this pencil, in order to pick up a digital tool, or this actually works in other settings also. If I need to draw my pencil using pencil and paper, which is of course the finest technologies that there are, uh, this is also true. I have to abstract. I have to create a mental model, a mental concept of what I have to model. That, of course, it does not have to be the perfect mental model of an object, but I have to have a notion, an idea, an abstraction of what I will try to model and how can I mentally visualize it. So basically, for me, this is the link between abstraction and 3D modeling. So when we come to the idea of algorithms, sorry, this was a bit unexpected. I think it's the mail. 5 minutes, please. Listen. Aqui. Sorry, my dog gets a bit. Sorry, my dog gets a bit nervous. These things are alive, so I don't have much control over it. So where was I? The idea of algorithm. Lisa, no. The idea of algorithms. So what do you have to do in order to create a model in 3D? You have to understand the model, you have to have the mental idea, but also you have to know, or you have to establish a method. Which steps do you have to take in order to recreate as well as you can the model which is in your mind? So for this, you have to mobilize your technical knowledge, and of course, you have to also find the better steps, the most effective steps in order to recreate using digital tools, 3D modeling, what you need to model in 3D. Next up is the idea of logic. So logic is transversal to this whole approach, because you always have to do the logical steps. And of course, look at them and see if they are effective for your process, and if they are not effective, finding ways to better your modeling process. This is the big one for me. When I started learning about the computational thinking frameworks and its main tenets, its main approaches and components, this is the one that got me seriously thinking about 3D modeling and computational thinking, the idea of decomposition. Remember at the beginning when I said that it was very important to create a mental model of the object you are trying to model? This is why. Because if you are modeling an object, or if you are just drawing, you have to know where to start. And with some modeling tools, specifically if you are using primitive 3D modeling tools, you have to understand which shapes can be used to describe and recreate your object, your model. When I start to do the practical part of this workshop, this will become, at least I hope so, crystal clear. So basically, we need to break the whole into parts. We need to look at our object, even an imagined one, and understand how can I break it up in simpler elements in order to use simple 3D shapes to describe and to assemble them into a complete 3D model. So for me, this is the spark that's allowed me to understand the connection between computational thinking and 3D modeling. So this is a very easy concept to describe, the idea of pattern recognition, and I'm just going to ask you, um, if you need to model a building facade full of windows, do you really need to model each window by itself, or can you just focus on modeling one window and then repeat the pattern, copy it along the facade? Of course, it's the second one. Do one and then repeat it. So in here, it comes the idea of pattern recognition, the idea that we can, during the modeling process, we can look at our objects, at our ideas, and find which parts are unique and which can be repeated, which can be patternized. And finally, an idea that is transversal to this whole approach is the idea of evaluation. It's not, it's always, it's a, how can I say this? It's a constant process, because while we are modeling, we are constantly thinking, am I doing this right? Is it, does it look like it's supposed to? Can it be improved? Am I doing it? Am I doing it right? If it's not accurate, if it's not right, what do I have to do? What changes do I have to make in my personal 3D modeling algorithm, in the steps that I'm using? What is wrong, for example, with my abstraction model, with my mental model of my object? So evaluation in here is not about assigning a grade, or but about capacity, about being able to look in real time at your modeling process, at the way that you are working, understanding if you are doing it right, and if you feel that you are not doing it right, to take necessary steps in order to make it more efficient to improve it. So this can be done. This looks extremely hard to do because, I mean, it's very abstract, logic, composition, etc. But actually, if you just challenge the kids with a very specific projects, it's actually very easy to do by doing it yourself. And that's where the other aspects of computational thinking enter, the idea of debugging, the idea of resilience and perseverance. Because remember, 3D modeling is never easy at the beginning. It's always a bit hard, so we can't give up. Just try and try and try. Don't give up. Don't just give up because it seems hard at first. 3D modeling is an error-prone process, so we need to constantly debug. Why is it? Why the mistake, or it's really a mistake? And finally, the idea of trying and retrying. So, and the idea of trying and retrying new stuff. So, how can we do this with our students? The first thing to do is making it clear. If you are teaching them about 3D modeling, don't just teach them the tools. Don't teach them how to use the tool. Explore with them how to create a 3D model. This is what I do with my students. Hence the whole 3D approach. The idea that I'm just the idea that I'm just that I'm exploring with my students everything. So, and the second thing is challenge them how to disassemble an object. It's not by mistake that I'm using a pencil, because the idea is look at the object you're trying to model and then disassemble it. Finally, I believe it works great with primitive modeling, which is the most basic modeling technique. Every one of you that uses Tinkercad application knows about primitive modeling. It's about using simple shapes to create complex objects. It's one of the first and one of the best tools for children, because I believe the cool thing about primitive model is that it forces you to think, because if you have a very limited palette of objects, of shapes that you can use to recreate a complex shape, you have to think, you have to look, you have to abstract, and you have to understand how to better use those shapes in order to um, better create your models. So how shall we do this? I like to use 3dc.io, which is an Android and iOS application. It can also be used in a web. You can go to 3dc.io.com, use the launch editor, and you can very easily create a 3D model on the web. Of course, on the web, for the web, there are better applications like Tinkercad. I have no problems in saying that Tinkercad is far better than 3dc.io, but 3dc.io allows me to do something that Tinkercad doesn't, which is to work on any mobile phone. Tinkercad works on mobile devices. It's not completely mobile unfriendly, but it does not work in small mobile devices. While 3dc.io was designed specifically for mobile devices. I'm just going to launch my application over here. 3dc.io is, I believe, something very interesting also because you may have heard about this guy, Simon Papert, right? The computer scientist that at the end of the 60s started to propose the idea that computers could be excellent tools to capacitate children, to empower them, and more than that, he also fostered the development of of programming languages. They're specifically designed for children. And one of his key concepts is the idea of low floor, high ceiling. Just going to minimize a couple of things and then maximize another. Então, okay. Deve falharmos. As I was saying, Simon Papert, as you may well know, fostered a couple of amazing concepts. One of which is the idea of low floor, high ceiling, which are environments that are very simple to start to use, start to understand, but can be explored and explored and explored in novel ways, in deeper ways, uh, allowing for deeper knowledge, deeper understanding. Probably the most best known example of low floor, high ceiling approach is the Scratch programming language. I believe I don't need to introduce that, but I'm bringing you this concept in order to show you that the app that I'm using, which is 3dc.io, can also be very, very, very useful as a low floor, high ceiling. Of course, 3dc.io is not the perfect 2D app. It's actually very primitive, very simple, sometimes too simple. But if you are working with young children, you don't need complex stuff. You need simple stuff that you can challenge them, that you can spark them and make them believe in themselves, in their abilities. So as far as 3D modeling is concerned, remember what I'm going to show you now is of the 3D model. It will seem extremely simple, extremely basic, but remember, this is not about you nor me. This is not about your abilities and capabilities as 3D modelers, nor about what you can do with 3D modeling. It's about how you can teach this to young children in ways that they don't feel it to be difficult, in ways that you can also explore computational thinking concepts, and basically in ways that you can leave a spark for your students to better understand 3D modeling and to use, to empower them to use digital tools as the creative media tools. So I'm just going to fire up the application on my mobile device, 3dc.io, which is free to use. And the first thing you are going to see as soon as the app opens is the login screen. And the cool thing about the login screen is that even though it invites you to use Google or Facebook to create an account, you do not need a social media account or an email account to freely use the to freely use this application. This is extremely important if you are working with children because I'm in Europe, I'm in Portugal, and we take very seriously the protection of data privacy of our students. We have to. GDPR forces us to think very truly every time we use an application that requires data from our students, especially when they are young students, which, as you may know, GDPR considers a specifically vulnerable target audience. So the cool thing about udc.io is that it does not need internet, does not need accounts. All the processing is done using your mobile device, either a phone or a tablet. So instead of beginning logging in with Facebook or Google, I'm just going to use the continuing without an account. And there you go. This is the main interface of 2dc.io. Before starting to show you how can you use 2dc.io to foster computational thinking skills in your students, I need to show you the basics of the tool because I mean it's like the alphabet. You need to know the alphabet before you can start to write a literary text, for example. So basically, what are you seeing? You are seeing a black space with a grid. The grid is basically the word plane, and you are seeing a cube. The cube is a primitive, which you can move in the X, Y, and Z axis. And as you can see, I'm using my fingers to move it across the 3D space. If I need to rotate, I just need to touch my screen and then move the finger around. And if I need to zoom, it's the pinch and zoom mode. If I need to do other operations than moving an object around, I need to change. Right now, you are seeing on the right side of your screen the 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 the, the move manipulator activated, and now I'm going to touch the second one, which is the dimensions, in which I can deform my shapes. 3D3dc.io is not about precise modeling. There are some measurements in the application, but they are not. How can I say? I cannot define accurately which measurements I need. Finally, the third icon on the right side allows me to commute into rotate mode, in which I can rotate my shapes. In the left lower corner of my screen, there are three icons: Add, Color, and Edit. In Add, I can add more primitive shapes. I just need to touch them, and it places them at the center of the screen. And then I can deform, rotate, move around as I need, as I fit. In Color, I can assign textures. In the free version of TDC.io, you are limited. Or I can assign specific colors, or I can use a color wheel to assign a specific hue of color. Finally, on Edit, I can do the grouping, subtracting, cloning, deleting, uh, touch, untouch operations on a 3D model. Okay, now the challenge now will be how to model a pencil. Why this? Because it's the way it's a very I think it's a very quick way to understand how you can apply or actually how you can develop computational thinking skills with your students using 3D modeling. So I'm going to explore how to create a simple model in an activity that allows me to do a couple of things. First, it allows me to explore the computational thinking skills. Second, it allows me to show my students what I'm going to do to you right now is what I do to my students in remote teaching or in physical teaching. Allows me to show them how they can work with the tools of this application in order to create a 3D model. But before doing that, I need to show you something. I need to show you how bad a teacher I am. This happened in pre-pandemic times, I mean about 2 years ago, in which I had students coming up to me
Hi,
and
sorry to interrupt. We can only see the green screen or the orange screen saying how to 3D see. We can't see anything else.
Sorry, sorry, Jackie, I did not understand. You are seeing.
All we can see is an orange screen with the QC code. We can't see.
Okay, I see. You have
we can't see anything else.
Okay,
yeah.
So I see. Thank you. Just going to stop sharing. Thank you for advising me because I had no idea. I see the problem. Okay, so now there you go. Now you are seeing the application. Sorry.
Thank you
for the heads up. So I have to restart. Sorry. So I'm going to make it quicker. Just going to start. So as I was wrong application. Sorry. Don't get nervous. This kind of thing happen. So I'm going to just run how to use 3D modeling in this application, which it's not better nor worse than other applications. It's very useful because you can use it in any mobile phone, in any tablet, without internet, because it uses only the resources of your device. And as I was saying, now it's very visible to you. You can use social media logins, but you do not need to use that. You can use it freely without any account, which means that the privacy of our students is paramount in this application. So second thing is how to use the app. You are seeing a work plane, which is this dark space with the grids, and you are seeing a queue because every time I start a new project, it always starts with a queue. If I don't need the queue, I just click on edit and then delete, no problem. But the cube now is useful for me to show you the three modes of modeling into this.io. First, you can reposition the object, move the object on the X, Y, and Z axis. If you need to rotate your point of view, just put your finger on your screen and then rotate it. If you need to zoom in and out, it's the pinch and zoom, movement. And of course, the second, at your right, you'll see three specific icons. The cross is for the move tool. The two arrows are for the deform tool. How can you resize your objects? Deform tool into this.io as a quirk. I will explain that later. And finally, how to rotate your object in the X, Y, and Z axis. Secondly, in the lower left corner of the screen, you'll find three icons: add, color, and edit. You are seeing in Portuguese. I'm saying it in English because if you install the app, you'll see it in other language than mine. So in add, you have access to the primitive shapes which you can use to create your model. If you compare this, for example, to Tinkercad has a lot more shapes to work from. But if you look at the shapes that Tinkercad offers, most are essentially variations on these simple shapes. This is why we call it primitive modeling. Second, color. I can assign a texture, or I can use swatches to apply a specific color, or I can use a color wheel to apply a specific tone and hue and value. Finally, on edit, I have the modeling tools, the subtract, the group, the cloning, deleting, and of course, selecting and unselecting an object. So now, as I was saying, the idea is trying to explore how to create a model, but within the computational thinking framework. And but when I was thankfully interrupted, I was going to show you our mistakes as teachers are extremely important to learn how to be better teachers. So I'm going to show you a project created by one of my pupils. He was at the time, this is pre-pandemic, he was at the time a pupil of mine in my robotics club, and he came up to me. Our robotics club works uh, in our school library. It's very open and it's very free. So the kid comes up to me one day and with his small mobile phone, smaller than my mobile phone, and he shows me an amazing crane, very well designed. Given that 3D modeling with primitive modeling and 3D.to is a very simple application, um, he showed me what I believe it was an amazing project, a crane. And I told him, kid, that's an amazing project. What are you planning to do next? He tells me that he loved birds, so he started to do some research and tried to. And at the end of a couple of minutes, he comes up to me and he shows me another bird from a photograph that he told me that it will be his next project. I've actually looked at the kid and told me, "Hey man, Peter, his name was Pedro. Uh, I know you did an amazing crane. This is what the original crane that you can see, but you see, 3D modeling on a mobile device is not very perfect. So I don't believe you will be able to do such a complex bird as you are now showing me that you want to do." He looked at me and then he basically went away. In the very next day, comes up to me and shows me what you are seeing right now. The first object, the larger bird, is the original crane, the one that I looked at the kid and tell me, amazing, because you've understood, for example, that you can just create an outline in order to have more complex shapes. And this is the other bird that my student tried to model, and I did not believe he would be able to model this. He was not only able to model the bird, of course, not as accurate as other modeling techniques would be able, but he also created an entire scene in order to show me that yes, he was able to do it. So I love it. I love it when my students contradict me, and I love it when my students go way beyond my expectations for them, because it means that they are really learning, and it means that they completely appropriated the technology. Because the focus of this cannot be the technology used, cannot be the learn 3D modeling because it will be important in your future. Is experiment with 3D modeling because it can be an important tool to express your ideas. Another thing that I want to show you again, as I was saying, this comes from my teaching practice, comes from my classroom, is basically this. Imagine that one of your students comes up to you and tells you, teacher, I need to print my project for history class and shows you the project on her smartphone. Which project? Basically, it's a mail carriage from the 800s. And teacher, of course, I needed to 3D print it. This is an example for me how kids can be empowered, because I mean, when the history teacher shall challenge the students to create something for history class, this student, which knows a bit about 3D modeling, understood that with her smartphone she could do with the project and she could explore new ideas. So, but onwards, let's start a new project so that I can show you how can we connect computational thinking and 3D modeling activities. So this is the 3D modeling how-to. This will be no different than the 3D modeling workshop on Tinkercad or SketchUp or other 3D modeling tools. The one difference is that I will steer the 3D modeling process in order to connect with the computational thinking framework. So the very first thing, as I was saying, is to look at an object and see, create the mental model, abstract your object in your mind. And the second thing is to decompose it, to look at it and look at your very limited palette and understand. You have to recreate this pencil. So how can you do it? Which tools? Which shapes can you use? And this is explorable. This can be done in a class with a group of students and asking them these questions. Look, in your laps, in your hands, in your smartphones, in your tablets, you have this application. You know that I've shown you that it can do very cool things, but you have a very limited palette. So how can we explore them? How can we do this? The best way, I believe, is to work with them, to make them think about what they are doing. So the very first thing is, what of all these shapes is the one that I can better use to recreate the pencil? And kids will always say, teacher, use a cylinder. So there we go. We have a cylinder, but the cylinder is not exactly pencil shaped. It's short, it's large, and the pencil is long and very narrow. So this is the part in which kids have to understand the difference between moving and deforming. So I'm just going to deform the cylinder in order to make it longer and to make it thinner. And for this, you need, as I was saying, the abstraction, the mental model. I'm just going to change the color in order to be better seen. So basically, this gives you the body of the pencil. Now comes the second part. How can I recreate the tip of the pencil? It's also very easier. Remember, this is easier for us, maybe not so much for kids, but are having their first introduction to 3D modeling. But look at it. Which shape could I use to better describe this tip? Kids will of course say, "Hey teacher, use a cone." So I'm using a cone, but big problem, kids. This cone does not look very much like the tip of a pencil, and also as another problem is larger than the pencil. And kids will already tell me, teacher, like you did with the body of the pencil, just resize it in order to make it fit in the pencil, and then move it up so that it will fit the top of the pencil. And then of course we can also be a bit more rigorous in our modeling process. I won't be very rigorous today because of course we don't have that much time. Just going to change the color, for example, for okay. So now we have another problem. This is where I try to use computational thinking skills to understand about Boolean operations. Is that the tip of the pencil, actually mine is broken, is actually a different shape, a different color than the wooden part. So how can we do this? This is where I tell my students, in 3D modeling with primitive shapes, we create complex shapes using simple primitive shapes. We do it in two ways, by grouping shapes and of course deforming and reposition, of course, and rotating them, but essentially by grouping simple shapes into complex shapes. But sometimes we need to do cutting operations, to do subtractions. That's what I'm going to show you right now. So I'm going to touch edit and then touch the cloning tool. And I'm going to put this clone a bit farther away from the main body of the pencil. And now I'm going to use another shape to cut the tip of my pencil, because I need to cut the tip in order to create another shape that will have different color. So I can use any shape in Tinkercad, as you may well know. This is done using the positive, negative shapes. In 3dc.io, any shape can cut another. You just need to intersect it, and then on edit mode, choose subtract. I always ask my students, did something happen? And they tell me, no, teacher, nothing happened because you are still seeing the cube over there. So let's just delete the cube. And as you can see, the tip of the pencil has been cut. The tip of the cone has been cut. So all I need to do is to move this one over here to the center, change the color, a bit of a bright red, and make it a bit smaller in order not to intersect too much. Oops, I believe I mistakenly. This thing happens in real time. Okay, a bit better. Okay, okay, okay. Now this one needs to be a bit thinner. Okay. So what you are seeing is a very simple object. But remember, in order to do that, you had to develop a mental model. You had to understand which shapes could better describe. This is, of course, decomposition. You have to understand which tools could you use in order to deform and manipulate the shapes to better fit your modeling. You have to develop an algorithm for modeling, and of course, you have to learn about the very basics of 3D modeling, like Boolean operations of grouping and cutting. Now, I'm going to up the difficulty because pencils generally have a rounded tip. So let's do round tip. So for this, I'm going to put my pencil away, and I'm going to ask, as I was saying, if this was one of my classes, my students, I'm going to ask, so your pencil has a rubber tip, a rounded tip, which shape can you use? They were looking at it and saying, teacher, we don't know, maybe a cylinder. Okay, a cylinder may be useful, but it will not be as useful as you may believe. Let's make the cylinder white. Let's see, if I mix a cylinder with a sphere, and then if I deform the sphere in order for the sphere to be more compressed, maybe I can find the better way to this. Oops, sorry. I need to select both of my shapes. Maybe I can find a better way to describe the rounded tip. And if I want to be really, really precise, I can do it far better. Okay, so now I have the tip of my pencil. I just need to create a group because these are two objects. Now, as I was saying a while earlier, resizing on 3dc.io has a quirk. If you are resizing a simple shape, it will always be deformed. If you are resizing a group of shapes, it will always resize. It will always resize in proportional mode. Just going to center my original object, setting 0, and resize the tip in order to better fit. Okay, not perfect, but I don't want to waste your time. And let's group it. Not perfect, I know, but I don't want to waste your time. And now let's rotate it to horizontal. Okay, so now there's just one thing that we haven't explored with this activity, which is the idea of pattern recognition. The idea that I don't need to focus and meticulously recreate every part of my model, because I can just copy what I need. So this is not the best pencil to show it, but some pencils have metallic grooves to hold the rubbers, etc., erasers, etc. So this is my challenge to my students. Okay, if you have a metallic groove on your pencil, how can you do it? Then I'll show them the menu, the shapes menu, and they look and try to explore with them which shape can be better used to simulate the grooves. They may tell you a cylinder, and in this part, I generally steer them to another shape, to the torus, and show them, look, there's this shape called the torus, which you may know as something that you like to eat, which is a donut, and you can use this shape to recreate the groove. How? Let's put it in the middle. Let's drag the torus to the end of the pencil. Let's change the color of the torus to look metallic. And now let's just deform the torus to be thinner and smaller, intersecting the pencil. Thinner, smaller, intersecting. And now the thing is, you have one of these shapes. What do you need to do in order to have more shapes? If the kids answer you, teacher, just go to add another torus and repeat the process, they are not learning right. But if they tell you, teacher, just copy and paste what you've just done. Perfect. So how do you do that? On your mobile phone, use edit and use the cloning tool to basically clone as many instances of your object as you need. And of course, if you are smart, you can clone more than one shape. You can clone as many as you would like. Clone it and move it, and now you are now creating the shape of the metallic grooves of your pencil. So pencil is done. And I believe with this very small, very simple activity, I've shown you how you can explore 3D modeling. How can you teach 3D modeling and challenge your students to understand 3D modeling, and doing it in ways that they have to think in computational thinking ways. They have to think about abstraction, they have to think about decomposition, they have to think about pattern recognition. Remember, and of course, and establishing algorithms, because everything I've done here is the 3D modeling algorithm I want my students to learn. But of course, I don't tell them this. I don't tell them, let's decompose the pencil, or let's decompose the bird. I challenge them with, of course, funny project, creating flowers, creating birds, etc. But the idea, the process is this: make it transparent. Don't just tell them, "Hey, look, touch on add, there's a cube, touch on pyramid, there's a pyramid, and now you have a house." No, don't do that. Explore with them how to do it, show them the beginnings, give them simple starting algorithms, and of course let them do the rest. And as you can see, they always do something way beyond our expectations. Okay. So I believe I've addressed the unmutes about the app. Can I export straight to 2D printer? Okay. So the answer is no. I don't know of any 3D printer that connects to a tablet, but you can export your projects to 3D printers. How? On the top of the app, there's a menu, and you can use save project to save your file. And you can use the export options. There are 3 types of exports. I prefer to export in Collada format, DAE, because it exports with color information. You can export as OBJ, and of course you can export as STL. And every time you touch export an object, it will generate a file which you can share with anyone. You can share using any application on your device. I usually tell my students to email me their projects, and then of course we can use any school computer that is connected to 3D printer to 3D print it. Okay, so I cannot directly print from my tablet. I need a computer to do a couple of things. The first thing, of course, is to receive my object. The second thing is to check for the validity of the STL to, to belay any mistakes in the modeling process. It's going to go back to the presentation. Okay, so right now you are seeing again our screen, or at least I hope so. So as you can see, the outcomes of this type of approaches is that we are able to connect art and ICT, which is for me terribly important. The idea that creating a 2D model is essentially a mental challenge, because every time you have to model something, you have to translate your visual mental model to your hand, to the alphabet of shapes that you have, to the techniques that of 3D modeling that you know. The idea that children can use their mobile devices for creative tools, and of course, this allows us to develop computational thinking skills in interdisciplinary settings. Because generally, when we think about computational thinking, we think about algorithms, about programming, about coding and robotics. And I hope I've been able to show you that we can do other types of activities using digital tools, using creative digital tools, and within them foster computational thinking skills. What you are seeing are photos from projects created by my students. They're not perfect, but they're done by young students. And remember, this is one of the great powers of 3D modeling and printing in education. The idea that kids can model their own stuff and then hold it in their hands is extremely powerful for them. So I'm coming up to the end of this workshop, and please, any questions, of course. I am the first to put questions. The very first question that I put is this relevant? I mean, can computational thinking be fostered using art-centered activities? Can I use mobile devices, creative tools? Is this relevant, or I am arming my students by steering them to mobile devices and not more traditional computers? Or maybe I'm overgeneralizing. I mean, this is an open idea, an open workshop, an open question. Everything I've told you comes from my teaching practice. It's not a closed idea nor paramount truth. And of course, thanks for the patience for listening to me. You can find me by email, f575@evp.net, or on my social media accounts, or on my blog, in which you can see projects created by my students on 3D and other technologies. And now I'm just going to stop. Okay, so anyone wants to put a question? Anything that you need to or would like me to? Thank you. I hope I have not mangled too much the English, even though we speak English very freely. When we are speaking English within a framework, sometimes it can be very awkward. So first, a couple of questions for you. Okay.
I have a question. So yeah, first of all, thank you. That was very interesting. My question is, how many students actually go to a PC then and continue working, or how many students are actually happy to stay on mobile?
Okay. It's hard for me to answer you that, because as I've said, this year I've worked only with mobile devices. We have to close down our ICT. To better explain this, I have a computer lab at my school, but this year, due to the pandemic, we try to find ways to limit the movement of students at school. So each group of students was assigned to a specific room, and that's where they had all the classes, even the practical ones like art education, like music and ICT. So I dragged a suitcase full of tablets. and of course use their mobile devices. Some students prefer computers. If actually, even though 3dc.io is an amazing application for mobile devices and not so much on computers, there are students that prefer them. Some students, this is my experience from the robotics lab, are multimodal. They understand that, for example, their mobile device can be fun to create a quick prototype or to do a more complex model because they can do it everywhere. They can sit on their couch and just model. But if they want to do something a bit more complex, they will go to a computer. So this is also important to underline. This app is not the perfect 3D modeling app. This is one of the many ways which you have in order to express yourself and to put your ideas on the screen, and if you are able to print it on your 2D printer. Don't know if I've answered your question.
Yeah, got it. Cool. Thank you.
I'm assuming you're Italian?
Yes.
Right?
Yeah.
Teacher, maker, Fab lover?
No, I'm a curious parent. I have 2 kids, so yeah, I'm trying to get engaged, and yeah, they seem to prefer mobile. They go towards mobile. But yeah, I found it like I'm a old school, so I always try to put them back to a computer with a mouse and a keyboard.
I know, but for me, this type of approaches are ways of interconnecting both worlds, showing that they can do a lot of things in the mobile. And I don't know if your experience as a parent, but maybe you felt that your child loves the mobile too much for the wrong reasons or for the not right reasons, because I think it's amazing to be able to game on your mobile, and you're trying to steer your child to more how can I say, more productive uses of mobile devices. Am I right? So, changing topics. Have you tried coding on a mobile device?
I personally, yes, because that's what I do for my job. I'm a coder, and I've tried it as a curiosity, and that's why I stopped. Like, I was very curious, especially in the early days of tablets. You can make Android apps on tablets, but it's just not worth the effort, basically.
Okay, but for educational purpose, remember, I'm an educator, not a coder. In fact, as I've said, I'm an arts teacher, so basically coding for me is how can I put this? A learning process. I'm learning coding while I teach coding, which is somewhat scary, but it's important for us teachers to be able to walk out of our framed areas and then just try new things with our students, because you have to empower our students. So I had a problem. You may know about the Scratch language. The Scratch environment is perfect, but it's problematic on small phones. So I found this very cool application called Pocket Code, developed by an Austrian university. I can't remember exactly why, exactly the name. The very cool thing about Pocket Code, it allows you to do very simple programs, like for example this, in which the camera sees me, the camera doesn't see me, okay? And you do it using exactly the type of coding that you would do on Scratch, but adapted for a mobile device. What can kids do with this? Let's see. Okay, this was a small game created by a 10-year-old girl. It's very simple. I think you have to try to catch this blue thing. I'm an old guy, so I can't game. Okay, so this blue thing, and very simple, okay? But if you look at the code, I'm a terrible gamer, as you can see. If you look at the code, each object has its own specific code. She had to learn about looping, she had to learn about sequencing, she had to learn about conditions, and she had to learn about variables. This for a 10-year-old on her mobile phone. This is for me the cool part.
Yeah.
It's going to stop my sharing.
What was the name of Pocket Code?
Pocket Code, yes.
Yeah.
It's free. It's actually cooperates with the Scratch project. There's a bit of MIT in this project. It's not perfect. Sometimes it's quirky in terms of interface, and sometimes the translations of the language translations, volunteer process, of course, and it's amazing, of course. Sometimes are a bit iffy, but it's powerful for your students. The very first cool thing that I have as an experience in Pocket Code was I showed the students how to create small animations, basically change the actor, okay, with very short timings in order to look like they are moving. And then I showed them how to create a small compass using the mobile phones. And the next day they were looking at me, teacher, look at my mobile phone. I can find the north with what you taught me. It's cool. It's ways of using mobile technology, but then of course I always have to tell them, look, you can do these things with these tools, but if you look at go to computer, you can do other things. So basically, I think we can balance, you can even things out, and I feel that mobile interfaces are growing and evolving. So maybe in a couple of years we will be able to do much more. But of course, I think if you want to go deep, you always need the keyboard.
Cool. Thank you.
Okay, more questions, please. Be my guest. Okay, I'm just going to show my, okay. The syllabus for Jackie. Let's see, how can I help you? Basically, what I do is teach coding, robotics, and 2D modeling, and basically that's it. That's my syllabus. I could share with you my syllabus, my curricula, but it will be specific to Portugal. In Portugal, we have a curricula, an ICT curricula that is actually quite ambitious. We need to, at 5th, 6th, 7th, 8th, and 9th grade, we have to work with them with a lot of tools, with a lot of technologies, and with a lot of computational skills. For example, at 10 years old, we have to challenge them to develop coding algorithms. When they are 11, we have to challenge them to start to use robotics, either by coding, programming small robots, or and also by using boards like Microbit or Arduino. At the 7th year, which is 13 years old, it's basically about learning how to do video, 3D, multimedia to express themselves. At the 8th grade, when they are 14 years old, we have to challenge them ICT to pick what they've learned before on coding, on robotics, on 3D, on multimedia, on video, on audio, on digital image, and apply them to create knowledge for the internet, to develop home pages, to develop small sites, to develop blogs, etc. And at the 9th year, when they're 14 to 15 years old, we focused on a more specific tool, namely file sheets, text processing. No, I'm having a whiteout. Processamento de cálculo. On tools like Excel, sorry, I did not want to use a name of a specific tool because they will need to deepen those tools for the later use of education. But while we do that, we also have to challenge them to understand a bit about artificial intelligence and about how to code mobile apps. So basically, I think it's the answer to your question. And
thank you. There's a building site happening outside, so I didn't want to keep unmuting.
Sorry.
No, it's okay.
You have a building. I have a dog. But sometimes
thank you.
So, any more questions? Please be my guest. Well, I hope this was interesting for you. That I've been able to show you that there is a cool link between 3D modeling, artistic, creative activities, and computational thinking, that we can explore that with our students, with our children, with our kids, with our pupils, in fun ways. I've taught you how to model a pencil, which is terribly boring. But of course, with my students, I would challenge them to create something a bit more funny. They would tell me what they would like to learn how to recreate in 3D, and my experience tells me that kids can be this can be an extremely powerful tool. And to finalize my session, I'm going to show them, because as I've said, everything that I'm telling you about comes from my practice, and this is what my students were able to create using mobile devices. Yes. And this is what the younger students, I believe that the younger students are sometimes more creative and more free on their approaches, because they do not understand that they are doing a difficult thing. So since they don't believe they are doing a difficult thing, they just keep doing it, and they keep creating very, very fun stuff. For example, everything I'm going to show you right now was modeled using mobile devices, sometimes very, very small mobile devices, in class. And the cool thing about using mobile device in education is that the physical classroom kind of disappears. It could be quite annoying. I'm joking, of course, but it could be quite annoying. Every time I had a break between classes, and I had an interval, kids would come up to me at my office or at the playgrounds with their mobile phones in hand, and telling me, "Teacher, this is what I'm doing. Is it going right? Is it going wrong? Do you like it?" And of course, and I was like, "Man, I just finished a class. I need 5 minutes to breathe. But of course, I think you are doing a great job." So it kind of makes the physical classroom disappear, and they start to use other times when they feel inspired to create something. So this is what I do as a teacher. As I've said, everything that I would share with you comes from practice, comes from the ground, as some theoretical aspects. But the main thing is that this came from my observation, from my teaching practice. I hope you have enjoyed it, and I'm going to wish you, just finishing this, I'm going to wish you an amazing day, and also an amazing continuation of 516 experiences. Thank you for your patience. Thank you for listening. Thank you for your advices. Thank you for telling me that I was not sharing my screen correctly. And goodbye, everybody.
Thank you.
Thank you.